The topic is evaluating the double integrals by converting to polar coordinates. So let's evaluate double integral from 0 to 2. Since this is dx, we know x goes from 0 to 2. So x is going from 0 to 2. And then the inner integral is with respect to y. So the y goes from negative x to x. So we need to convert it to polar. Before we do that, we need to draw our region. We know x goes from 0 to 2. Now we need to draw y equal x, y equal negative x, and y equal x. Let's start with y equal x. Y equal x, when x is equal to, x equal to means y equal to. So I know y is going to be equal to. So here's y equal x. Now same thing for y equal, to draw y equal negative x. When x is equal to, I know my y will be negative 2. So here's negative 2. And of course x equals 0 will give me y equals 0. Same thing here. X equals 0, y equals 0. So that's why we're using these points. So my region is this region. So this is my region B or R or D. I think we call it D. Alright, so let's call this integral 1. So now this is going to be a little bit harder. I know my theta will go from here, but this is what? This theta will be, so this theta will be negative pi over 4. And it's going to, this is pi over 4. Because y equal x, tangent, if that's simple. Tangent of, for example, this angle, tangent of theta will be equal 2 over 2, which is 1. That's why theta will be pi over 4. Same way for negative pi over 4. Tangent will be negative 1, will be negative 2 over 2, over 2, which is negative 1. So theta will be negative pi over 4. So the theta go from negative pi over 4 to pi over 4. Now the radius is tricky. The radius should go from here to here. So it should go from 0, but this is in rectangular coordinates. The equation is x equal to, let me do it here. X equal to means r cosine theta is equal to, so r will be equal to over cosine theta in polar. So these two are equivalent. This is in rectangular and this is in polar. So it's going to go from 0 to 2 over cosine theta. And then we need to do r dr d theta. So r, because the function is just 1, r dr d theta. Alright, so this is going to be equal, so we'll do the inner one first. That will be equal r squared over 2 between 0 and 2 over cosine theta. And the theta will go from negative pi over 4 to pi over 4. Now this is going to be equal, we're going from negative pi over 4 to pi over 4. If we plug it into r, we'll get 4 over cosine squared theta. What did I do? Everything over 4. So I can write the 4 here. It's the same thing, right? 4 over cosine over, yep. And then minus 0 d theta. We simplify that, we'll get integral from negative pi over 4, 1 over cosine square is secant squared theta d theta, and that would be just tangent, because derivative of tangent is secant squared. So this would be tangent of theta from negative pi over 4 to pi over 4, which means tangent of pi over 4 minus tangent of negative pi over 4. This is a good problem. Tangent of pi over 4 is 1, minus tangent of negative pi over 4 is negative 1, which is equal to 2. And that's it for this example.